May 2023 CSEC Mathematics paper, question 9. Now, it says L, M, and N are points on the circumference of a circle with center O. Then P, Q is a tangent to the circle at R. Alright, I already copied this part of the question over here. It says you have P, Q is a tangent to the circle. This is PQ. Tangent means it touches the circle. It doesn't cut the circle, it just touches it. Angle PRL equals 48 degrees. You have angle PRL 48, you see it here. Then angle RON is 156. You have angle RON 156 degrees. Good. Find the value of each of the following angles, given reasons for each of your answers. Show all working where appropriate. You have angle R. Let me just make a note of them here. Angle R. Then angle E. Angle E. Angle A. We have angle A. Okay. So, we see what happens in this case. We want angle R. Now, remember, do not watch any of these videos in their entirety until you work out the question. Make a genuine attempt at working out the question, whether before you start watching the videos or when you reach a certain point you pause. Then you try to work out the question at that point. So here now, angle R. This is angle R. Now, I can see a certain circle theorem arising here. Let me see something here. One of these circle theorems is this. If you have a card and you have the center of a circle, you have an angle that lies on the card at the center. You have another angle that lies on the same card at the circumference within the same segments of the circle. Then, if you have this angle being x, then this is half x. In other words, if this angle at this circumference is x, then the angle at the center is 2x. It's going to be twice. Right? One particular example is where you have a diameter with 180 degrees on it. If you have a card lying on the diameter, then you're going to have 90 degrees on that card. So here, the center, the angle at the center is 180, the angle at the circumference is 90, half. Right? Half of the angle at the center. So let's see what's going to happen here now. Suppose we make a bit of change to this. And we say this is our card. And this is the angle at the center O. This angle here. Then we look at the angle at the circumference in the same segment. Right? This angle here. Oh my. This angle is around this side. Let me make a bit of change to this. Yeah, the angle is around this side. Now, if this is x, this is 2x. Alright? Now, the same segment, the same argument can be applied here. Now, remember, as I said before, just to remind us, angle, and keep making these mistakes, you know. Yeah, it was correct the first time. It's over here. Why did I put it back here? This is 2x, right? Because if this is the circle and this is the diameter, you'd have 180 here, and then here now, you'd have a 90, right? Good. So that means you're going to have to find out what angle is over here. And whatever angle is over here, this R would be half of this. Alright? So, let's see what's going to happen here now. What's this angle here? The whole angle in the whole circle would be with 360. Alright? So this angle would be 360 minus 156. Which is what? Borrow 1 from 6, you have 5, 6, 7, 8, 9, 10. This is 4. 5 minus 5 is 0. 3 minus 1 is 2. This is 204 degrees. What is half of 204 degrees? It's 102. So 102 degrees, about that. So R is 102 degrees. As for reasoning it out, you would show the calculation. You would say that the angle RON is 156. So the supplementary angle is 360 minus 156 is 204. And then angle R is half of 204. Alright? Because it's angle that 204 is the angle that lies on chord Rn at the center. And R lies on the same chord at the circumference in the same segment. So what you have there would be half of it, 102 degrees. Alright? So that's my reasoning there. Now, angle E. Let's erase some of these things. I want to find angle E. Where's E? Okay. So we need to find angle E here. Let's see what's going to happen here. Now look at this triangle. In this triangle here, you can see it's an isosceles triangle. This angle and this angle are the same, alright? Now what I'm saying, if I can find out what this angle is, well, this is 90, because from here to here is 90, because it's the angle between the tangent and the radius at the point of tangency, where the radius and the tangent meet. You see that? So here, angle ORQ equals 90. Then triangle RON is isosceles, and then you calculate what angle ORN is. So you know that angle ORN plus angle ONR plus the 156 equals 180, right? So ORN and ONR, call them x each. So 2x plus 156 is 180. Then you subtract 156 from 180, right? So what do you get in that case now? 180 minus 156 equal 24. So 2x equals 24. So x would be half of 24, which is 12. So this is 12 degrees, all right? So if you come from here to here, 90, and then you back off 12, what you have is 90 minus 12. So E equals 90 minus 12, which is 90 minus 10 is 80, and then minus 2 more, 78. So E would be 78 degrees. I hope you get the reasoning, right? 78 degrees. After that now, what happened? They want A, angle A. This is something here now. Angle A they want. Let me erase some of the rough work. So it's 12. Let's erase parts of this. So we know this is 12. And this is 12. Want A. Okay. So let's see what happens here. What I'm looking at is this. We have this angle A here, lying on the chord NL. And this angle here, the angle NRL, lies on the same chord but in the alternate segment. You see that? So, let me make a triangle, a circle here. With a situation somewhat similar to this. This would be like A here, and this lies in the alternate segment. Now the thing is this: when you have the same chord where two angles lie on it in the alternate segment, those angles at the circumference in the alternate segment, they add up to 180. It's like when you have the circle and you have the diameter. This is 90. This is 90. Alright? And these 90s add up to 180. Alright? So, the situation here is that angle A plus angle NRL equals 180. But what is angle NRL? Well, you have part of it already. The thing is, you have E. E is what? E is 78. So this part is 78, and you have 48. You know, from here all the way around is 180 degrees. So if you have 180, then you back off 78 and back off 48. You're going to get something. So here, let's go back for our calculator. You have 180 degrees, right? On PQ, which is a straight line. You back 78 from off 180. You take 78 off, you get 102. And you take the 48 here. You take the 48 off, you get 54. So this is 54 degrees. Alright? What then? What you have here is A plus 54 is equal to 180. So A would be 180 minus 54. 180 minus 54 is what? Borrow 1 from 8 to get 7. 10 minus 4 is 6, 7, 5, 6, 7, 2. And then 1. So A would be 126. So A is 126 degrees. Alright? So that's what we have there. R, E, A. Have R, E, and A. Alright, part B is bearings. We're going to look at part B in a different video, but these are what we have for our answers for part A. Look at part E, the bearings part, in a different video.